So today we have an interesting geometrical theorem. We take a circle. Now we inscribe a triangle ABC inside it. Now we inscribe a circle inside this triangle. Now the circle that is inscribing the triangle is known as the circumcircle, and the circle that is inscribed inside the triangle is known as the incircle. Now we draw three congruent pink circles inside the triangle such that each of these circles is tangent to two sides of the triangle, and the three circles meet at a particular point inside the triangle, and this point is just a random point. Neither it is the incenter and neither it is the circumcenter. Now if the radius of these congruent circles are A, radius of the incircle is B, and radius of the circumcircle is equals to R. Now because of the arrangement of the diagram, there is a beautiful relation between A, B and R, that is 1 upon A equals to 1 upon B plus 1 upon R. So this is Anmol, and now let us see the solution. How can we prove this theorem? So first of all, we will start the solution by utilizing the fact how the pink circles are arranged in the diagram. So there are three things that defines the position of the pink circle. The first thing is that all the pink circles are congruent to each other. The second thing is that each of these pink circles are tangent to two sides of the triangle. And the third and the most important thing is that all these pink circles meet at a particular random point inside the triangle. The point where they are meeting is neither the incenter or neither the circumcenter. It's just a random point. Okay. Now look in this particular pink circle having the center D. So we can see that the circle is tangent to two sides of the triangle. So if I simply draw a radius to that particular points, the angle over there would be 90 degrees. Okay. Now I will simply draw a line segment that will join the points A and D. So now we can see that these two right angle triangles are congruent to each other because of right angle hypotenuse side. So once two triangles are congruent, rest of the things between them become equal. Therefore, this and this angle become equal. So now we can see that the angle A is getting bisected into two equal parts. Therefore, the value of each part would be equals to angle A upon 2. Okay. Now take the green circle that is ultimately the incircle of the triangle ABC. Hence the circle is tangent to all the three sides of the triangle. So here we have drawn the radius to the tangent points, hence the angle over there would be 90 degrees. Now I will simply draw a line segment joining the points A and O. Okay. So we can see that this triangle and these triangles are congruent to each other because of right angle hypotenuse side. Hence these triangles would again be equal. So we can see that the angle A is getting divided into equal parts. Hence the value of each of the part would be A upon 2. So here we can see that the line segment AD was forming an angle A upon 2 with the base of this triangle. And again the line segment AO is forming an angle A upon 2 with the base of this triangle. Hence the slope of both of these lines are equal. This means these 3 points are collinear points. So if I draw a line from the point A to O, it will also pass to the point D, and it is going to be a straight line. Okay. Now the same thing will happen with this triangle also. I will simply draw the radius to these tangent points. The angle over there would be 90 degrees. This line would have an angle C upon 2, and from O to C if I join, the angle again would be C upon 2. Hence this line would be collinear because slope of both of the lines are equal. So if I draw a line from the point O to C, it will also pass to the point F, and the same thing over here. Okay, so here we have drawn too many line segments. Now let us give the length. So first of all, the distance from the point A to this tangent point, I will give the length M. So the length from A to this tangent point would also be equals to M. Similarly, the distance from C to this tangent point, I will take it as P. Therefore, the distance from C to this tangent point would also be equals to P. And the distance from the point B to this tangent point, I will take it as N. Therefore, this length would also be equals to N. And this is happening because these triangles were congruent to each other. Remember that. Okay. Now we can see that the radius of the pink circle is given as A. So all these yellow perpendiculars that you can see in this diagram have a length A. And similarly, the radius of the green circle is given. So all these orange perpendiculars that you can see have a length B. Okay. Now carefully look over here. Now as we have seen before, these two angles were equal and they were having a value A upon 2. So in this particular right angle triangle, the value of tangent of A upon 2 would be equals to perpendicular upon the base. So the perpendicular is the radius of the pink circle, hence it would have a value A divided by the base. So base we have taken as a variable M. Okay. So here we have the value of tangent of a upon 2 in this triangle. Now take this bigger triangle. In this also the angle is a upon 2. So from the perspective of the bigger triangle, the value of tangent of a upon 2 would be equals to perpendicular upon the base. The perpendicular is the radius of the incircle, hence it would have a value b divided by. Now the distance between these two perpendiculars, I will take it as x, okay? So similarly the distance between these two perpendiculars would be again x. This is all because of the congruency. So now in this right angle triangle, we have got the length of the height, that is b, and the value of base is now going to be m plus x. Now we can simply compare these two equations. So we will get a upon m equals to b upon m plus x. Now I will solve this equation in order to get the value of x. So for that, if I do the cross multiplication, am plus ax would be equals to bm. Hence the value of x would be equals to m times b minus a divided by a. This is the value of x, okay? Now the same thing we will do on the other side. These two angles would be equal and it would have a value c upon 2. Therefore in the smaller right angle triangle, the value of tangent of c upon 2 would be equals to a upon p. In this bigger right angle triangle, so we have the height, that is the radius, and this remaining length I will take it as y. So in this bigger triangle, the value of tangent of c upon 2 would be equals to b divided by y plus p. Now I will solve this equation in order to get the value of y, and that would be p multiplied with b minus a divided by a. So here we can see that we have got the value of x and y. Now by congruency, if this distance is equals to y, that distance over there would have a value y again. So this time I will take this distance as a variable z, so that distance over there would again be equals to z. Now these two angles would be equal and it would have a value b upon 2. Therefore in the smaller right angle triangle, the value of tangent of b upon 2 would be equals to a upon n. In the bigger right angle triangle, the value of tangent of b upon 2 would be equals to perpendicular, that is ultimately the radius of the incircle, hence it would have a value b divided by n plus z. So when we will solve this equation, we will get the value of z equals to n multiplied with b minus a divided by a. Now I will just erase some of these things so we can move ahead in the solution. Now in this particular diagram, the value of x plus y is the distance between these two yellow perpendiculars. So according to these values of x, y and z, the value of x plus y would be equals to m plus p multiplied with b minus a divided by a. The same thing we can do in order to get the value of x plus z and the value of y plus z, okay? Now look in this diagram carefully. This is the straight base of this triangle. These two are the yellow perpendiculars and both of them have the same length, that is the radius of the pink circle. So if I will simply join the heads of these two perpendiculars, this line is going to be parallel to the base. The perpendicular distance between two parallel lines is always equal. So by the converse, these two lines are going to be parallel. Similarly, if I draw a line segment like this way, this line is going to be parallel to this side of the triangle, and similarly a line segment like this way, this would be parallel to this side of the triangle. Now in this particular quadrilateral, all the four angles are going to be 90 degree by collinear, hence it is a rectangle. In rectangle, opposite sides are equal. Therefore, the base is having a length x plus y, so this length would also be equals to x plus y. And similarly, this and this quadrilaterals would be rectangle, hence the length of this line would be equals to y plus z, and the length of this line would be x plus z. Now the most important thing present in the diagram is this white triangle. So I'll simply remove rest of the unwanted things. Okay, so here we have a very neat and clean diagram. Now look carefully. The vertices of this yellow triangle are ultimately the center of these three pink circles, okay? Now we will utilize the most important fact that all these pink circles are meeting at this particular point. Now if I draw a line segment from the point D to this point, it is going to be the radius of this pink circle, hence it would have a value A. Now from the perspective of this pink triangle, if I draw a line segment from this point to point A, it is going to be the radius of this circle, hence it would again have a value A. Similarly, from the perspective of this top pink, a line segment from the point F to this particular point of intersection is radius of this circle, hence it would again have a value A. Now we can say that inside a triangle we have a point, and from this point the distance to the corner is equal, hence this point is the circumcenter. So using that point we can simply draw a circle, and that is going to contain all the 3 points of this triangle. Now this thing can be utilized very beautifully. So for that I'm just redrawing the diagram outside. So we have a circle like this way. The triangle is present like this, this and this. Here we have the center of the circle and this distance are equal and it has a value a. Now this point is the center of the circle. Now recall the theorem that the angle subtended by a chord at the center is double the angle subtended by the same chord at the circumference of the circle. Hence if I take this angle as theta, this angle over here would have a value 2 times theta. Keep this thing as it is. Now the distance of this line segment was equals to x plus y. This line segment was having a distance z plus x and this line segment was having a distance y plus z. So as per the values of x, y and z, let us find the value of x plus y, y plus z and z. The value of x plus y is going to be equals to m plus p multiplied by b minus a divided by a. The value for z plus x would be equals to m plus n multiplied with b minus a divided by a. So for this triangle we have got the value of all the three sides and one of the angle is the angle theta. So from that perspective the value of cos of theta using the cosine rule would be equals to m plus n the complete square plus p plus n the complete square minus m plus p the complete square and this thing divided by 2 times m plus n multiplied with p plus n. You might be thinking where this b minus a upon a gone. B minus a upon a was present in all these three terms. So when you will do it perfectly, you can see that it will get cancelled out from the numerator and the denominator. So here we have got the value of cos theta in this triangle. Keep this thing as it is. Now to move further in the solution, I have drawn one more diagram over here. So let us see that what we can do with it. So till now we have utilized all the facts related to the in circle and the pink circles. But what is remaining is the circumcircle. So let us utilize that thing. So this blue point is the center of this circle. Hence if I draw the line segment from this point to the corners, it will ultimately be the radius of this circle that has been taken as capital R. Okay. Now the same theorem over here, from a chord the angle subtended at the center would be double the angle subtended by the same chord at the circumference. So if I take the angle subtended at the circumference as alpha, this angle over here would be 2 times alpha. Okay. Now the complete length over here would be equals to m plus p plus x plus y. We got this value for the base because of the previous marking that we have done in this diagram. Okay. Now if I will replace the values of x and y that I have got previously, the value for m plus p plus x plus y will be m plus p and this thing multiplied with b upon a. Similarly the value of this side would be equals to n plus p multiplied with b upon a. And similarly the value of this side would be equals to m plus n multiplied with b upon a. Now in this triangle we have got the value of all the three sides and one of the angle is the angle alpha. So by using the cosine rule, the value of cos of alpha would be equals to m plus n the complete square plus n plus p the complete square minus m plus n the complete square divided by 2 times m plus n multiplied with n plus p. So here we have got the value of cos of alpha and previously we were having the value of cos of theta. And surprisingly we can see that the right hand side of both of this equation are same to same. Hence we can compare the left hand side. So cos of theta equals to cos of alpha. This gives me the result theta is equals to alpha. Hence the angle theta is equals to the angle alpha. So if the angle theta is equals to angle alpha, 2 theta would be equals to 2 alpha. I will simply take cos on both of the side. Therefore cos of 2 theta equals to cos of 2 times alpha. Now what if I tell you that we can easily get the value of cos of 2 theta and cos of 2 alpha? Recall that in this particular circle the angle subtended at the center was 2 times alpha. So we can simply apply the cosine rule in this triangle. The side lengths are m plus p multiplied with b upon a and the adjacent sides are r and r. Now what about 2 theta? So recall this circle. In this circle also the angle subtended at the center was 2 times theta. And that is present in this triangle. The side lengths are a and opposite side is x plus y, that is m plus p multiplied with b minus a upon a. So from the triangles that we have just seen, the value of cos of theta would be 2a square minus m plus p the complete square multiplied with b minus a upon a the complete square divided by 2 times a square. This thing would be equals to cos 2 alpha. So that was present in the triangle. Side lengths were r, m plus p into b upon a. So 2 times r square minus m plus b the complete square multiplied with b square upon a square divided by 2 times r square. So from both of the side we can simply cancel out the 2 and do the cross multiplication. So what we will finally get is 2a square multiplied with r square. This term over here multiplied with r square equals to this term multiplied with a square minus this term over here multiplied with a square. Now we can see that 2 times a square r square, 2 times a square r square got cancelled out from both of the side. Now we can simply factor out negative m plus b the complete square from both of the side. It is in multiplication. Over here a square and a square got cancelled out. So what is finally remaining is r square multiplied with b minus a upon a square equals to b square. Okay. Now we can take root on both of the sides. So we will get r multiplied with b minus a upon a equals to b. If we do the cross multiplication, we will get r multiplied with b minus a is equals to ba. By opening the bracket on the left hand side, the thing will turn out to be r times b minus r times a. Now I will divide both of the sides by r times a b. So on the left hand side we can see that rb got cancelled out. So what is remaining is 1 upon a minus. Now in this term ra and ra got cancelled out. So what is remaining is 1 upon b equals to, now over here ab and ab got cancelled out. So what is remaining is 1 upon r. Now by moving this term on that side, we will get the value of 1 upon a equals to 1 upon b plus 1 upon r. And that's the answer that we were looking for. So this was my way to solve this particular theorem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.